Today is the first session, first week's session. So we will not be very tough on the questions and answers. It will be easy one to practice and also to answer. We can start with a little bit of introduction of yourself so that I can understand your background and I can explain accordingly. So maybe we can call out the names. Usha Raju, can I have?
Yeah, sir. This is Dr. Usha Raju. I'm working as an associate professor in Pusa, DSU Pusa campus, Delhi.
Okay, sure. So you have already finished your PhD. Okay,
Yes, sir.
you're again taking this course. Okay,
So this is just for my progress.
okay,
NPTEL.
okay,
I keep joining these courses. I keep on doing these courses.
okay. I am actually a PhD student, so I don't
Okay.
know how much I am qualified to give the
But this
answers.
is new topic. No problem. This is a new topic for me.
Okay. Uh,
Okay.
we'll go to the next person. Maybe Orchona Kumari. Can you
Yes, sir.
tell a bit about your background? From which branch you are and I mean, have you again also finished your PhD or you are working or you are a student like that way?
Sir, I have finished my PG.
PG means masters.
Oh, yes, sir. Yes, sir.
Okay. In which branch?
Sir, I'm in science.
Okay, nice. Mm. Amol Shivkumar, Amol Shivankar. Yes, you can go ahead with telling your background a bit, telling us about your background. From where are you? Uh, your BTech or MTech subjects or BSc, MSc, whatever you have done. Maybe Amol is not there.
Amul, you have to unmute yourself.
Okay. Okay, Vishal, you can go ahead. Vishal Bhaskar.
Hello.
Yes.
Sir.
Can you please tell us a bit about your
Uh,
background?
Sir, I have completed my master degree in chemical engineering,
Okay.
and I have recently joined in Sugar Tech College as an assistant professor.
Oh, great.
Uh, yes, thank you.
Okay. So it's quite time. We can start. Just wait. Let me share my screen. I have also actually done chemical engineering. So I'll share my screen. Hope my screen is visible to you.
Yes, sir.
Yes, sir.
So we'll start. Uh, so my name is Shutanu Sadhukhan. I am a teaching assistant for this course. A PMRF teaching assistant to be specific. So the other teaching assistants or TAs, what they do, they prepare the assignments and the solutions for you. And we actually basically discuss the concepts in a little bit deep. And also we discuss certain problems also so that you feel comfortable with your assignments, solving questions and also in your exam if you have registered for it. So this is my PMRF ID and I am also a chemical engineer. I have done my BTech from NIT Durgapur, MTech from IIT Kanpur, and I am a chartered engineer. And I am a Prime Minister's Research Fellow at IIT Bombay. Currently, I am working in Water Innovation Center, technology, research and education, or weekly lab. These are my YouTube and your Twitter IDs, so where you can connect with me, and also my LinkedIn and social media accounts are there, so you can also connect with me there, and you can ask any questions, your doubts and all. Also, if you during our session, if you feel that feel the need of asking any question, you can always unmute yourself and you can type your questions in the chat box. Okay, so this is the tentative overview of the Tuesday evening sessions starting from today, and there will be total 12 sessions, and at the last there will be one summary sessions before your exam, and the course instructor, who is Professor Bhelanki, he will also be taking 2 or 3 live sessions also. There you can ask questions regarding the course material that is being delivered in the weekly sessions. And there are actually 3 TS. So 3 PMRF TS basically. You can attend any one or any one TS session. You can attend all 3 also. And you can also even if you are unable to watch the 3 sessions, the recordings will also be uploaded. So I'll just go through a brief introduction of how to access the course material and all. So let me share my entire screen. Okay. So I hope it is visible. So in your Swayam portal, if you go to my courses, you will see the course appearing here with the name water and wastewater treatment. You may also take another courses; those will get populated here. You have to click on the go to course button. After that, there the weekly recorded lectures will be there at the left hand side, and from the first or second week, I guess, second week of February, I guess, the recordings of these videos also, and also the folder from where the presentation slides will be uploaded, those will get populated here. So if anybody has any problem with accessing those, they can ask the NPTEL team by email, or you can also contact me either by email or in my in this live sessions also. So here is a button that is ask a question. So by clicking there, you can post your questions in the forum. So NPTEL team will be checking this forum regularly, and they will answer your questions in a weekly or bi-weekly manner. So everybody is encouraged to do this. Now we'll return to our session. So I hope this is clear. If anyone has any doubt, they can unmute themselves and speak, or you can type your questions in the chat box. Okay. So welcome everyone to the course title. I hope it is correct. Water and wastewater treatment. It is your first week's interactive session, and the course code is C39. So today is 30th January 2024, and the course instructor is Dr. Bhanu Prakash Bhelanki, who is environmental engineer and a professor at the civil engineering department of IIT Roorkee. Okay, so we are at the first week. We'll start our session with an interesting video for you to motivate you for the course. Hope the audio is visible, right? Audio is audible, right? Okay. So if the audio is not audible, you can unmute yourself and tell. Okay. Why it is not working? It's not. Maybe we have to stop the laser batteries.
If you try to drink water from the ocean, it will be salty. It will dehydrate you and eventually kill you. This is why no one drinks ocean water. But what happens when you have nothing else left to drink? See, I am now in one of the driest countries in the world, the Emirates. It's a country with very little water. It has 0 rivers, it rains 10 days a year, it is surrounded by salty ocean water, and 90% of its groundwater is also salty. In other words, 10 million people live in the desert with not enough water to drink, not for humans or animals. This isn't just the Emirates. 99% of the world's water cannot be drunk. It's just too salty or too frozen. But for the first time ever, I want to show you the step-by-step process of how this country found water. The first thing they did is collect the only water they have, ocean water. Then they built this. Tens of these factories that specialize in one thing, removing salt from water. They take the ocean water, pressure it, and put it through a filter that does not allow salt to enter. Salty water goes in here, and fresh water exits from here. This is a crazy complicated process. Every day, not thousands, not millions, billions of liters of waters are cleaned this way. Every day, billions of liters of ocean water enter salty and leaves clean. Now, 90% of the entire country's water comes from the ocean. It is the highest in the world. Okay, so we're here at a farm in the middle of the desert, and I have this. This water came straight from the ocean, and it was desalinated in the process, and now you can use it to actually, feed the animals, feed the plants, and it's very cool, it's very warm, and it's very drinkable. That's magic! The next thing they did is even crazier. Instead of cleaning water, they created new water. And this is a true story. They sent planes all the way to the clouds and released salt in the air. They have a lot of it. Because of the salt, the clouds grow bigger and bigger, and eventually they rain fresh water into the country. This is called cloud seeding, and in 2017, they did it almost every single day. And when that water falls to the ground, they catch it. All the rainwater they collect here by building a huge dam. And this fresh water is what keeps the people alive. I don't think people appreciate this enough. But this water is fresh water, it's rainwater, that was supposed to go to the ocean and become salty. But they caught it before it went to the ocean in the middle of a dam, and they made this lake. But most importantly, you can drink this water. From desalination to cloud seeding to dam building to well building, humans are doing the impossible just to find water. And the big idea here is simple. If we have to go and seed clouds and do all this complicated stuff, the least we can do is save water when we can and turn off that water sink.
Okay. So in that video, we saw many concepts. I think the audio was audible to everyone. And Okay. So the one concept was there that they told about is cloud seeding. So where you don't have to treat the water, right? You can directly harvest the water from clouds. There are basically two types of water treatment. That's why the name of the course is water and wastewater treatment. Water treatment comes if you consider a chemical plant or any other plant. Before using the water into that plant, the water must be treated. Mostly the hardness is removed, the saltiness and the ions, those are present inside the water, and also big particles, those are present inside the water, they are removed. That is your preliminary water treatment. And after the usage of the water, when it comes out of the treatment plant, then the water is treated, because in the process, when the water is used in the industrial processes, that water becomes contaminated. So after usage, this is called as the wastewater treatment. So both these aspects will be covered actually in this course. So in that video, we saw a thing about the cloud seeding. So I'll just ask you a question regarding this. So the cloud seeding process is a process that involves the introduction of various chemical agents into clouds to enhance the chances of precipitation. That is your raining. Okay. So which one of the following institutes in India has undertaken a significant test flight last year with the aim of cloud seeding on June 22nd? Option A is IIT Bombay, option B IIT Kanpur, option C IIT Roorkee, and option D IIC Bangalore. You can type the options in the chat box. Okay. Varun Dev has given answers. So let's see what others have to say. You can type the option in the chat box, whichever you feel right, and don't get shy away in answering those questions, because this session will not be evaluated. This is just for practice in a very relaxed mode. So if you are taking less number of courses, you can attend these sessions live, because it is 2 hour session. And if you have less time, you are attending many other NPTEL courses, then you can go through either the slides or you can watch the recording. Okay. So expert services provider is saying it is IIT Kanpur. Okay, IIT Kanpur. Most of the people are saying it as IIT Kanpur. We'll see. So option B, IIT Kanpur. Whatever you have said is correct. Okay. So in that video that you saw, one another concept was told. So they are considering the cloud seeded water as the new water, right? So in Singapore, there is a concept of new water, but that is entirely different. Here they are collecting the fresh water from the cloud. So that comes at the upstream upstream stage, right? That is after before the usage of the water, we are collecting that water. So these kind of treatments or collection, whatever, that comes at the upstream processes, and they are calling it new water in UAE. But in Singapore, after treatment of the sewage, that is the domestic wastewater, they treat it very well and make it drinkable. So after the treatment of the wastewater, whatever water they get, they call it as the new water. Okay, and there was actually in our country, people will generally drinking water comes either from underground or from potable water comes from the river after treating the river water by the municipality. But if you treat the sewage water, people will not generally and make it to the drinkable quality also. People will not generally drink it. But in Singapore, they are very that is kind of you can say they are very uh, the people they are that much open minded. So whenever the new water came into the picture, the Singapore politicians just stand on the stage and they held a hand of their each other, and they just drank that new water in front of everyone to increase the public awareness, and people accepted that. Okay, sir, just for your information. So we'll go to our next slide. So there is a little bit of information regarding the cloud seeding. So it can be done by various processes. One is by chemical or salts. So within the chemicals or salts cloud seeding, there are dynamic seedings, static seedings, and it can be done by electric charges. The electric charges technology is what the UAE is using from 2021 commercially, though they introduced this technology in way back 2017. From 2021 they have started the regular usage of this. So in this process, drones equipped with payload of electric charge emission instruments and customized sensors are used, and the drones fly at low altitudes and deliver electric charge to air molecules for the precipitation to occur. Another process is called the IR laser pulse process for cloud seeding. In this process, electronic laser assisted water condensation mechanism is directed to the air above. It was first tested in Germany's Berlin in the year of 2010 by the researchers of University of Geneva. So these laser pulses, these infrared laser pulses basically encourage atmospheric sulfur dioxide and nitrogen dioxide to form particles acting as seeds. That's why it is called as the cloud seeding. The chemical or salt seeding is the most common method. In dynamic seeding method, the hygroscopic materials, example your common table salt, these are utilized for the to exploit the latent heat that is released by freezing. And in case of static seeding process, chemicals like silver iodide, potassium iodide, dry ice, which is nothing but basically solid carbon dioxide, and liquid propane, those are used to expand into the gas after release, and in this way the chemicals are used for cloud seeding. Upon sufficient growth, the liquid droplets become heavy enough to fall as precipitation from the clouds. These are just a bit of information. So all the slides and all the data and everything, the problems those will be solving, everything will be shared with you, so you don't have to take notes. So now in that video we saw, they told that if we drink too much salty water, you will get dehydrated, right? And also, but salt is also important to maintain the sodium potassium balance of our body. But at the same time, the concentration must be tuned so, to prevent the dehydration. So there is a question. So you have to answer which one of the following processes is responsible for getting dehydrated by drinking salt water. Option A is osmosis, option B is RO or reverse osmosis, option C is phagocytosis, and option D is endocytosis. You can type your answer in the chat box. You can type the options. It is just for practice. These sessions will not be evaluated. So feel free to answer. So whatever comes in your mind, you can type. Okay, expert services provider has given the answer as osmosis. Let's see what others have to say. Sharbojit is telling it as osmosis. Anyone else? Orchana. Okay. Orchana is also saying it as option 1. Osmosis. Okay. Most of the people are saying it as osmosis. Some people confuse it with reverse osmosis, but it is not. Most of you have said it correctly. So what happens that if you if you take an YouTube and put salt solution in one arm and pure water or salt solution of lesser concentration in the other arm and separate them with the help of a semi-permeable membrane, then what will happen? The osmotic pressure of the concentration of the side where the concentration is lower is higher than the side where the concentration is of the water concentration is less, that is the salt concentration is more. That means naturally the water will flow from the lower concentration side to the higher concentration side to balance the partial pressure of the water, partial concentration of the water. But if you apply pressure at the higher concentration side, then the water will flow from the first. You have to apply that amount of pressure which will balance the osmotic pressure difference basically. Then the amount of excess pressure you apply, that acts as the driving force for the flow of the water from the higher concentration side to the lower concentration side. This is an artificial process called as the reverse osmotic process, which is utilized in the desalination technology. Most of the desalination technologies, there are also thermal desalination technologies. These are membrane based desalination technology, and you get the pure water out of it. But osmosis is the natural process where if you put a cell, most of you have answered it correctly, to be the osmotic, all of you has answered it correctly. This is your osmosis process. So if you put a cell, what will happen? How does it get dehydrated? So this is the natural phenomenon of cells influx and outflux of the water. If the water comes inside the cell, it is called as the pinocytosis. If the solid products comes inside the cells, this is called as the endocytosis. This is called as the phagocytosis. Both are called the endocytosis process, which are there in the options. If something, either water or solid, goes out of the cell, that is called as the exocytosis, just like our excretion process, human body. So cell also does drink water and drink solid, eat solid products, and also excretes excretory materials. So what happens if the cell is kept at a higher concentration? Let's assume it is the membrane or the wall of the cell. Let's assume it to be semi-permeable, and if the concentration of the outside environment, the salt concentration or sugar concentration, whatever, it is more than the concentration of the cytoplasm, then that is the liquid that is present inside the cell, then this type of solution is called hypertonic solution with respect to that cell. If the concentration of the outside environment, salt concentration or sugar concentration outside the cell environment, is dilute as compared to the inside environment of the cell, then it is called as the hypotonic condition. If the outside and inside concentration are same, then it is called as the isotonic solution or isotonic condition. The isotonic solution with respect to the cell. Then what will happen? In case of isotonic solution, the amount of water that will come inside through the semi-permeable membrane inside the cell and the amount of water that will go outside, that will actually balance each other. So it will be a dynamic equilibrium will take place, and no problem will happen to the cell. If something happens that the dilute water comes inside the cell, it is possible in case of the hypotonic condition. So in that case, the cell will swell, and our question was the hypertonic condition, that is your dehydration. When the water is too much salty as compared to the concentration of salt inside the cell, then the water will go outside of the cell, and the cell will basically shrink, or dehydration will occur. Okay, so I hope this is clear, the concept. Yes, definitely. So Sri Krishna M, we will share the entire slides, so you don't have to take any note in the session. So what will happen in the course of action, we will come into solving several problems. So during solving those problems, you can just solve those problems in your copy, but mostly you don't have to take any notes of the session. So the entire everything, the recording and also the slides, everything will be shared with you. The sharing process will be started maybe from first or second week of February. So it will be available, the button will be available in the in your online module, that is your Swayam portal, and we will also show you how to access them through this through your through our sessions, only online session we will show you. And there are basically 3 tiers, so 3 sessions will occur. You can attend any one of them, you can attend all of them. If you are having other course load, the amount of other courses is, if it is less for you, you can attend all 3 sessions, it is up to you. But mostly the content will be almost same in the 3 sessions of the 3 tiers. One is two is are today only, and one will be taken maybe in Friday or Saturday, I don't remember. So you can attend any one of them or all of three them as per your convenience. Okay. So you don't have to take any note. Okay. So we will go to our next slide. Okay. So now we will solve a problem which is based on the membrane treatment of the water. So recommended per capita water supply levels for designing schemes is given as below. As this is a first session, so all of the content that is being shared, that is related with general water treatment processes, and it may not be uh, very hard and fast in a very hard and fast way. It may not be related with your content that you have to solve in your exams or in your weekly assignment sessions. So these are a bit in a bit light-hearted mode, but these are of course related with water treatment, and yes, everything will be shared with you, so you don't have to take any note. Okay. So now we'll solve this problem. So where in the left hand column classification of towns and cities are given, and the right hand column the recommended maximum water supply levels are given. The unit is LPCD, that is liters per capita per day. So number one is towns provided with piped water supply but without sewerage system. Okay. So this type of town, actually the recommended maximum water supply level is 10 liter per capita per day. Option 2 is cities provided with piped water supply where sewerage system is existing or contemplated. So they are the recommended level. This is just an example. Okay, so these are not generic things. This is just provided data for solving your problem. So this second type of city, the recommended level is 135, and the third type of city, these are metropolitan and mega cities provided with piped water supply where sewerage system is existing or contemplated. There the water supply level is 150 liter per capita per day. You can see the recommended maximum water supply level is gradually increasing as the water treatment and supply facility of the town is I mean the more the developed the water treatment facility of the town is, the more the recommended level of the water supply, right? So in the first option there is no sewerage system, but in the second and third options there are sewerage systems, so the water recommended level is higher. Okay, so I hope it is clear. So now this is the data provided. Now you have to answer. So the questions will be as follows. So in what has been asked. So here the type of city is mentioned. City is provided with piped water supply where sewerage system is existing. That means your second type of city, right? Then the population for a community is provided as 8,000. The source of water is provided as surface water. The characteristics of water to be treated is only suspended and bacterial impurities. They are telling it is present inside the water. And the number of working hours of the treatment plant is provided as 18. Now the questions are, you have to determine the total water demand, water to be sent for treatment, and treatment trend with membrane processes. That is, if you use membrane to treat the suspended and bacterial impurities that is present inside the water, what will be the type of the treatment trend with the membrane processes? And lastly, you have to decide the number of modules required if the flow rate per module is 120 liters per hour LPH. So there are two units, LPCD, liters per capita per day. Per capita means per head, and liters per hour. So okay, so we'll solve this problem together, right? This was the data that was given earlier. So you can go with your with solving the first question. So you just now you can take your notes, not for taking not for notes taking check. You can just calculate these things in your note. So you can calculate the total water demand, which is the first question, right? You can calculate and you can type your answer in the chat box. So you can see the population for a community is provided 8,000, right? And this is a city provided with piped water supply where sewage system is existing. That is, it is second type of city where sewage system is existing or contemplated. So this matches with this one, and it is recommended maximum water supply level is 135 liters per capita per day. Per capita means per head, right? So 8,000 is provided as the population for a community, and it is the maximum water supply level. So maximum, whatever the maximum recommended level is, that is only your water demand. Because you are designing your system based on the maximum demand only. So expert service provider has given the answer as 90, almost 99 liter. So the unit will be liters per day, right? Liter means demand for how long? That is a question. Liter per day or liter per hour or liter per year. That unit must be specified. Liter doesn't mean anything because people will be requiring continuous water supply. Okay, so I don't know the value, but the unit must be the time must be specified, right? So okay, we'll go with the solutions. So the solution of the first question is 135 liter per capita per day. So I think you have probably the unit time that you have changed, I think. Okay, so because the thing is that the 135, it is directly provided here. Even if you multiply it with 8,000 population, then also it will become as liters per day, right? That will be also a correct answer. But per day must be specified. Per capita may or may not be there. It depends on how you are how you are comprehending the question. So next option, question 2 is water that is to be sent for the treatment. So the total water demand liters per day So anybody is calculating? I will wait for you to answer. So the total water demand liters per day will be population for a community into per capita demand. So per capita demand is 135 LPCD liters per capita per day into 8,000, which is the population for the community. So per capita actually goes out and it becomes liter per day only. You can convert into MLD, that is megaliters per day, by dividing it with 10 to the power 6. So that will be your equals to 1.08 mlpd, megaliters per day, right? Okay. So before solving the other questions, we will be looking into a bit into the membrane process characteristics. So as in the questions it is told, only suspended and bacterial impurities are present inside the water. So to understand what type of membrane treatment to be used, we have to look a bit at the different types of membrane and their uses. So membrane type are basically determined by their porosity. So membrane pore can be in the micro range, can be in the ultra range, can be in the nano range, and can be in the RO range. Okay. So the term nano means 10 to the power minus 9. The term micro means 10 to the power minus 6. So the microfiltration membranes, those will have pore size of around the 10 to the power minus 5 to 10 to the power minus 7 meters. The nanofiltration will be your 10 to the minus 9. That means 10 to the power minus 7 to 10, 10 to the minus 8 to 10 to the minus 10. That is your 1 angstrom. This will be the range for the nanofiltration pores. And for the reverse osmosis membranes, the pore size will be below 1 angstrom, 1 angstrom or below. And ultrafiltration will be in between microfiltration and nanofiltration. Depending on their pore size, basically, their rejection is decided. So the larger bacteria and suspended solids, they get separated in the microfiltration process. The viruses, bacteria and suspended solids, they are separated in the ultrafiltration processes. So viruses are not separated in microfiltration. If it is present inside the water, you have to use the ultrafiltration. If you want to separate the multivalent ions, multivalent ion means what? The divalent ions, trivalent ions, etc. Just like calcium chloride, calcium sulfate, magnesium chloride, magnesium fluoride, magnesium sulfate, etc. These are all bivalent ions. So they cause the hardness of the water. If that water is used inside industrial processes or your utensils, you will see a layer of a white layer at the inside of that utensil or industrial equipment, which actually reduces your heat transfer coefficient, thereby increasing the risk of thermal accidents. So that's why the multivalent ions needs to be separated from the water before using that water in industry or domestic purposes. So either that can be there are other processes for removing of multivalent ions also, but in membrane technology nanofiltration is used. And reverse osmosis is something which separates everything from water, including the monovalent ions, which are just like your sodium chloride. It is a monovalent ion because sodium ion is a monovalent ion. Valent means I think you understand pretty well. Those of you who are having science background, they will understand it. But for general public sake, we'll discuss these things a little bit later. So reverse osmosis actually separates all of the things from the water, and only the pure water with a very low amount of impurities comes out. Right. So these are the membrane process characteristics. Now we will be returning to our problem. So we have seen the total water demand is 135 liter per capita per day, and the population for the entire community is 8,000. Water, as per the water balance, as Sad has told in the week's lectures, the water goes in, that goes out. I mean, it will not just vanish. So that's why the people, they will be consuming this water, right? And if you multiply them to that amount of water only will be going for the treatment. Whatever they will consume, the same amount of water is to be treated. If you consider zero liquid discharge facility, if the water is discharged, then makeup water must be taken into the picture. Otherwise, it is not required. Okay. Even if you are not utilizing that water, that time also there are environmental norms that you cannot directly throw that used water into the environment, because it will cause harm to the aquatic life. So that's why it must be treated. Now you have to choose the treatment train with the membrane processes. So here the source water contains the suspended and bacterial impurities only, right? So can anybody tell what type of membrane we have to use? Any questions about advection? Yes, yes, it will be there. I mean, if time permits, I have included those things in my slides. So if time permits, that I will discuss. Otherwise, I'll I mean go with them in the next class. So I think in the second half will be discussed with these questions. That is your from 8 to 9, right? So can anybody tell this thing, this question, answer this question? All of them? Not necessarily. Okay. So I'll go with the answer. So here microfiltration membrane treatment scheme will be sufficient, right? Why we will not use all the things? There are only suspended and bacterial impurities present inside the water, right? So suspended solids and bacterial impurities are present inside the water. Why we will not use the ultrafiltration, nanofiltration, just like expert service provider said, RO? Why you will not use RO even? So why microfiltration is your sufficient here? Can anyone tell this thing? Unmute yourselves and tell this thing, because all of the processes, ultrafiltration, nanofiltration, and reverse osmosis, as you have correctly said, they separate the bacteria or suspended solids. But why we are selecting only microfiltration here? Any insights? Okay, no one is coming forward. People are only concerned with things those are specifically in the whatever sir told. Not outside that, no one will say anything. Okay, so the reason is that the all of the processes basically separates the bacteria and suspended solids, but the other processes, ultrafiltration, nanofiltration, and reverse osmosis, are having finer pores, right? So to pass the water, that is the wastewater, through these pores, it requires higher pressures than the microfiltration one. Higher pressure means higher energy. That means higher pumping cost, right? And also the fabrication of these UF, NF, and RO membranes are costlier than MF membranes. So that's why both the capital costs and both the treatment costs because of the energy consumption goes higher in case of ultrafiltration, nanofiltration, and reverse osmosis. That's why we will use only the microfiltration in treating our water, where the characteristics of water to be treated is only suspended solids and bacterial impurities are present. If it was told that also viruses are present, then we would go for ultrafiltration. If they told that we have to separate the bivalent ions also that is present inside the water, then we would go for the or the hardness that is measured in terms of the calcium carbonate in the water. It is more than the permissible limit. Then we would go for the NF scheme also, that is nanofiltration scheme also. But as only suspended solids and bacterial impurities are there for our uh, for our economical reasons, we will only use the microfiltration schemes. Now, the last problem of this question is decide the number of modules required if the flow rate per module is 120 liters per hour. Here, I think the number of working hours of the treatment plan that you have to take into account. So, has anybody calculated it? I'll wait for 2 minutes. Around 8 p.m. we will take a break, and after that we will come. We will be solving questions as Borun has asked regarding advection and all. Advection, convection, and diffusion. These concepts we will understand, and we will solve questions related to that. So this is the first session, so that's why I am just giving you. In the first time, I didn't give you conceptual things. Conceptual means where you have to remember something. These are only numerical problems. So if you just know the calculation, you can do these things. Just you have to understand the terminologies. Anyone? Okay, I will give a hint. So data provided is flow rate per module, and you have to calculate the number of modules, that is liters per hour, and it is given as liters per day, and the number of working hours of the treatment plan is 18. So is anybody getting an insight? I don't think. Another hint. So water to be treated by a single module within the total working hours is 18 hours into 120 liters per hour. That means 2160 liters. One single module will treat this amount of uh, water per day, and water to be sent to the treatment, it is 108 this many liters per day. I think now it will be pretty clear to everyone. So the actual 24 hours demand need to be met within 18 hours time only, right? So therefore the total number of membrane modules that has been asked in the questions that will be required will be simply your this 1.08 megaliters per day divided by 2160 liters equals to 500 modules. And if you consider 5% standby, then it will come out to be 525. What is the concept of standby in any water treatment plant? Either standby motor or a standby pump or any standby membrane module or whatever the unit operation is. So what is the concept of standby? Can anyone tell why it is required? For maintenance purpose, yes. It is one of the major reasons for which the standby is required. So let's say the water is coming the raw water or the wastewater is coming, and there is one raw water pump, or there may be one sludge pump, or there may be another type of pump which is pumping the water into your system of treatment trains. And this pump needs maintenance. Definitely, that is the major reasons. And also this may get damaged. How will you understand the damage? In the suction side or in the discharge side, there will be pressure gauges, and or there may be online pressure gauges also. So the difference, that is the delta P of these pressure gauges, will be fixed in a continuous plant. But if you see that there is a variation in this pressure delta P, then you will understand that there is certain problem in the pump that either needs replacement or needs maintenance, or maybe certain uh, impurities has jammed the impeller, so that's why the pressure drop is increased, or many other reasons may be there. So that's why you need to actually check, or you need to maintain. So what happens that time? Then there is one parallel pump which is called as the standby. What will happen? There is two isolation valves. Those valves will get closed, and it will isolate the circuit, water circuit, and the other this valve will get opened, and this valve will be open. So that's why the water will be going through this circuit, and the other circuit will be used for maintenance. So this is the concept of standby, so that the pump operate, the plant operation, the water treatment plant operation doesn't get stopped. So that's why to maintain the continuous operation, the standby concept is there. In case of membrane modules also, there are certain modules, and with a certain number of other modules as the standby. So there you can see there is one online, and then the other one is the in standby mode. If one is in operation and the other one is in maintenance, membranes after certain times get fouled, so it needs to be cleaned. So in that time, the other standby module, standby train, actually it becomes operational, and the other things comes under maintenance. Okay, so the answer of the fourth question is 525. If we consider 5% standby. Now one bonus question for you is, if membrane train, if one microfiltration train contains 25 modules, calculate the number of microfiltration trains that is to be required. So it is nothing. So what is module and what is train? So the concept is very simple. So if you consider one membrane train, so one membrane train consists of several stages, like stage 1, stage 2, stage 3, and within each stage there are different modules. So more than one modules makes one stage, and more than one stage makes one membrane train, right? So modules are kept in parallel, but different stages, as per the different stages, the modules are in series. So what is the utilization of these stages? Basically, feed water comes in and concentrate goes out, right? And filter water permeate is comes out. So after the first stage, whatever concentrate you are getting, you are further actually separating, right? To make the process economical. So you are getting more and more permeate, and the concentrate is getting more and more concentrated. So that is the concept of stage basically. Either your focus is on the concentrate, that is in your fruit juice concentration industries and etc. But in our case, that is your water treatment, the focus is on the permeate, which is the water. Concentrate you have to throw out. In RO process, for example, the salt that is coming out in the concentrate, having higher concentration of salt, that you have to throw out. Either you have to throw out, or you have to pass it through thin film darts, agitated thin film darts, ATFDs, to evaporate the rest amount of water and collect the salt, and dispose it through waste management corporations who use those salts for landfilling purposes. So now, if one membrane train contains 25 modules, then what will happen? Simply the number of trains will be 525 divided by 25, that will be 21. Simple problem. Okay, so it is 8:02. We will take 8 minutes break, and we will start this session, restart this session at 8:10, and we will be solving problems related to your affection and diffusion, etc., and other concepts will be going with that. Okay, so anybody has any doubt regarding whatever we have done till now, they can ask questions, or you can take break and you can come back at 8:10 sharp. In the same link, we'll join. Okay, so we are back. We will wait for 30 seconds for people to return. Everyone has gone. I can only see two people. Okay, welcome. I'll come back. Okay, we will restart. Meanwhile, people will join. What are we? So nobody has any question regarding whatever we have told. Right, everything is clear, I hope. Okay. So next we will see this picture. So there are three graphs. All the three graphs is in the y-axis there is concentration plotted, and the x-axis distance has been plotted. Right. So everyone has the basic. I assume everybody have done basic mathematics course in class 2 levels. They can understand the graph because understanding from the understanding of 2 to 3 people's background, I understood that people who are attending maybe from a very I mean bachelor's or master background, they are having this understanding. But even if some people from non-science background is attending, and they are unable to understand what are these, they can ask question. What is this plot? I cannot understand plot or graphs. They can always ask questions. So I'll assume they can understand, right? So there is no question is a silly question. Everything is every question is justifiable. Okay. Even so, NPTEL actually it is not a very the courses are not designed for highly educated class or research class people. These are designed for common Indian people, common people all over the world only who understand English language. They can attend this course and they can make themselves educated, and they can enhance their understanding of science-based and non-science-based subject. So these are targeted for general audience. So even if whatever questions you are having in this mind, if you are unable to understand, you can always ask. Okay, it is highly encouraged. So now in this graph, these are plotted. Concentration versus distance profile has been plotted. Most of you can understand. So the flow direction has been given, and it is from left to right. That is your increasing distance. So if distance, let's say it is x, it is x equals to 0 and x equals to 1, 2, like that way. So from 0 to 1 to the higher distance values, the flow is in that direction. And the temperature that is provided here, these are basically isotherms, and temperature 2, that is it is providing from the flow is from the lower temperature to the higher temperature directions. There is one reason why, because the more the temperature, the more the less the concentration of gases or uh, that is your liquids.
Sir,
So as the
excuse
temperature
me.
increases,
Excuse me. Is this temperature or time? T1 and T2.
time also, because see, the question is you have to determine the type of the mass transport. Okay,
No, my question is whether T1 and T2 is indicate time or temperature. It can't
anyone
indicate
can be,
both the
if
things.
you consider them as time, then it is also correct, and if you consider them as temperature, then also it is correct. Temperature effect will not be there in case of the graph 1, but in the other graphs there will be temperature effects. But time, it is also correct, because T2 is greater than T1. You see the profile at lesser time, it is at the left hand side, and the more the time passes, you see the profile at the higher flow sides, that is at the direction of the flow. You see the if you consider an element of the fluid that is flowing through the path, then you will see that as the time evolves, how the flow pattern or how the profile changes. So both is correct, but the thing is that you have to determine the type of the flow based on the profile. What type of fluid flow is this? So you have to choose from the correct options given below. So this is graph 1, graph 2, and graph 3. These are profiles, flow profiles. So option A is graph 1 is affection, graph 2 is diffusion, and graph 3 is affection and diffusion. So these are concentration versus distance profile. It doesn't matter uh, whatever you consider. So the concentration versus distance profile only gives you the answer. Okay. So even if you don't consider the another T, even if you consider one profile, for example, the T1, if you consider T1 in this profile, if you consider T1 is this profile, then also you should be able to answer that, even if there is no transient change or no temperature change. Okay, so now option B is graph 1 is affection and diffusion, graph 2 is diffusion, and graph 3 is affection. And option C is graph 1 is affection and diffusion, graph 2 is affection, and graph 3 is diffusion. And option D is graph 1 is diffusion, graph 2 is affection, and graph 3 is affection and diffusion. So you have to choose the correct answer, correct option. You can type A, B, C, D in the chat box. So based on the flow profile, so the thing is that there is one flow element, right? So how the concentration is changing over the distance, if there are varying concentrations, so how the concentration is changing over the distance, that will be that must give you the idea of advection, diffusion, and both or both. So which graphs actually determines which? The thing is that diffusion we basically all know. It is your flow from higher concentration to the lower concentration, right? And the your convection everybody know, but advection many people may not know. For example, someone has rightly asked the question. Vodun has asked the question. So we'll actually basically come into explanation of what is advection. But diffusion, you know. So you at least one graph you should be able to tell. Okay, option D someone is telling. Graph 1 to be diffusion, graph 2 is advection, graph 3 is advection diffusion. So which one is diffusion? You just tell that one. That will be enough. Option A, okay. Option Orchona and Horitha has told option A. Okay. I think it is the correct answer only. We will see. Yes. So someone has told that T is the time. So I think it is more general. Yes. So if you consider temperature, then other way the flow can be flipped also. Some species may there are species which instead of decreasing concentration or decreasing the volume, increasing the volume, their density behaviors actually changes with increasing temperature. For example, water. If you heat it up to 4 degrees centigrade, it instead of decreasing its density, it will basically increase in density. So if you consider it as temperature, it will be more specific case. But if you consider it as time, it will be more general case. Yes, true. But nevertheless, it is immaterial. So whatever the importance of the T is basically to confuse you here. So even if you remove the T, you should be able to answer. Okay, so I know what is coming forward. So we'll go with the answer. So option A, the two of you have told it correctly. So option 1 is advection. So graph 1 is your advection, graph 2 is your diffusion, and graph 3 is advection and diffusion. So you can see this is diffusion, and both the effect of the advection and the diffusion is there in the third graph. So that's why it is advection and diffusion. So here you can change the change in concentration with respect to distance in case of diffusion, because you all know that in case of diffusion, flow only occurs from the higher concentration to the lower concentration. That's why the concentration changes over the distance, because flow is occurring over the distance. So that's why the concentration changes. And here it is coupled effect. But in case of advection, you see that there is a plug kind of thing is flowing, right? So it is not changing over the distance. The concentration is remaining either is remaining the same, or in a particular concentration, you can see it is called as your step, not step, it is called as the pulse kind of thing. You can see over a particular distance, you can see there is a sudden change in concentration. If the graph is like that way, stepwise, it will be a sudden change, and if it is not so, it will be kind of plug flow. Okay, so you can see that over the distance there is no change in the concentration, right? So if you consider the central point to be the if you consider the x-axis to be the central point of a pipe, and let's say the around that central point there is one the flow is occurring, then you will see across the y-axis the concentration is you're changing. but in case of graph 1 it is not changing. So and it is called as the advection. So now we will see what is advection basically. In case of heat flow, though it is your mass transfer, because water treatment actually it is mass transfer, but understanding of heat flow will be beneficial. Actually it will be easier for you if you understand the advection first in terms of heat flow. So in heat flow there are basically three things. One is radiation, another one is convection, another is conduction. If you bring a rod or a pipe, whatever, a solid material inside the source of heat, the material, the particles of that material will vibrate, and the heat energy will transfer from one end to the other. That is called as the conduction. The heat energy without the help of any medium will directly flow. That is called as the radiation. And another phenomena is there, that is called as convection. Now, sometimes what people do, they confuse between the advection and convection. They think that whenever there is a flow of any property by the motion of the particles themselves, you can see in the conduction there is no motion. Even if you can see there is a motion of the particles, but the average position of the particles remains the same over time, because they are just vibrating. They are not changing position as a whole. They are just vibrating, so their mean position is remaining the same. In the radiation there is no media, but the media itself is carrying the heat in case of convection. If you consider this picture, your the problem, so you will see here the concentration is basically the amount of particular pollutant inside water, or particular salt, or particular bacteria, virus, etc. inside the water, right? It is the concentration. So in heat flow case, the heat is being transferred by the motion of the particles. In our water flow case, that particular species, salt, uh, bacteria or other pollutant, heavy metal, etc., that is being transported by the motion of the particles, water particles, right? So that's why people tend to confuse between the convection and the advection. But what is the basic difference? In convection, there is one thermal component. Thermal gradient is there. So that's why by heating, the lighter the density, the intermolecular gaps becomes larger. That's why density becomes decreased. So that's why local elements of the fluid becomes lighter and they flow stop, and the heavier, that is cooler element, comes down. In this way, the thermal component actually catalyzes the flow of particular property from one region to the another. But in case of advection, there is no thermal thing. You can see, you can think this like that way. So there might be pressure gradient for which the water is flowing through the pipe, or just because of the Brownian motion, the bulk property transfer may takes place. The property may be your concentration or maybe heat, etc. So there is no thermal component in it. So the flow, or the flow of the fluid, or flow of a particular species inside the fluid is not caused by thermal gradient or density difference. Understood? So that's why, though it is flowing from higher concentration to lower concentration, but the reason of the flow is because of the bulk motion of the particles in the absence of any thermal gradient. Absence or present, that is immaterial. So thermal gradient is not participating in the flow of the particles. That is called your advection. Though sometimes they are synonymously used, but is a bit difference is there in between them. So I hope it is clear to everyone. If anyone has doubt, they can ask. Otherwise, we'll proceed to our next problem or question.
Sir, is advection really related to flow of heat? How?
Please repeat your question.
My question is the process of advection really related to flow of heat? Like radiation, conduction, convection is all
Uh,
right. Is it
radi
really advection is also related to heat flow?
no, no, advection may or may not be related to heat flow. I just introduced the heat flow concept to, I mean, understand the difference between other convection, conduction, etc. But these are not basically related to liquid flow, which is in our case water transport. So they are only advection is there, diffusion is there, convection may be there, but conduction and radiation will not be there. Conduction and radiation, these are only related with your your heat flow. In our case, that is your liquid flow, water. There will only be convection, advection, and your diffusion. Yes. So convection is something. If there is thermal component, let's say there is one let's say there is one bottle, and within that bottle the lower portions contains higher concentration of some material, and the upper portion contains lower concentration of some materials, and you are just heating at the bottom, right? So because of the thermal gradient, what will happen, there will be a circulation motion that will be present inside the water, right? So that's why there will be mixing, or there will be flow of the material whichever is present inside the water, and it will become homogeneous. From heterogeneous mixture, it will become homogeneous, right? So that will be your convection. What is advection? If there is no thermal component, still it is getting mixing by the bulk motion of the fluid. How? Let's say you are just doing this bottle like that, or you are just pouring that water. So the water is coming out and it is in a very turbulent thing. So that's why because of the Brownian motion or random motion of the water, because of the bulk motion of the water, the uh, species transport is occurring. Species means it may be pollutant, it may be bacteria, or it may be other liquid component, etc. So that's why mixing is occurring. So this type of flow of species from one place to other place is called the advection. Advection, yes.
And
And
I suppose that too in one direction only.
yes, I mean, the reason, the driving force is important here. And the third thing is your what I told, diffusion. Diffusion, here the driving force is the concentration gradient. For example, you just put a drop of sugar, or let's say drop, not the sugar. So if you, yes, sugar cube may be there, or you take one copper sulfate solid, that is copper sulfate crystal. You just put it in the water, and what will happen over time, it will gradually dissolve. So in one particular place it will give color, and gradually the color will flow. Even the water is still, even if there is no motion of the particles, still the species will flow from one place to the other place of the water, and it will homogeneous, but it will take time. That kind of flow is because of the driving force is important here. The driving force, if it is thermal, then it is convection. If it is non-thermal, because of the bulk motion of the fluid, it is advection. Even if it is neither of them, it is because of the concentration gradient only. It is a slower process, but it happens, then it is called as the diffusion. So these three are important in case of the fluid flow. Okay, so sometimes what people do, they just club these coefficients together and use them as the mass transfer coefficient. So later these concepts will come into the picture. There are fixed laws of mass transfer, and these kinds of laws will come into the picture. But now these are not, I mean, the first class, we are not going through all those detailed concepts. So here you can see within the mass transfer coefficients, there are components of convection also, components of advection also, components of diffusion also, or maybe sometimes convection and advection components are clubbed together, and only convective mass transfer coefficient, and another one is diffusion mass transfer coefficient. Like that way, the mass transfer coefficients are formed. So those are useful when designing one mixture or designing water treatment devices also. So those things comes into the design aspects, but this is just for the understanding of advection concept. Okay, so hope it is clear. So advection is both in case of fluid flow and both in case of liquid flow and heat flow. In both the cases, advection is there. Okay, and convection is also there in both cases, but radiation and your conduction, these two are specific to heat transfer cases, not mass transfer cases. So heat transfer, mass transfer, you may not, even if you are from chemical engineering or mechanical engineering background, you may know these things, or even if you are not, you may not know. That's why I'm not going detail into that. Whatever will be required for water treatment purposes, that we will discuss in subsequent classes. Okay. So hope it is clear. Any other question? Otherwise, we will proceed to our next problem. Okay. So if you get any doubt at a later stage, you can always post your question in the forum. Okay. So there are basically two statements. Statement one is mass transport in advection is along the direction lateral to the fluid flow. And statement two is in diffusion, mass transport is more apparent in the direction of the flow, direction of the fluid flow. Okay. So you have to determine which of the following statements is correct or both are correct. That you have to determine. So you can type your answer in the chat box.
So both are wrong.
Both are wrong. Okay. Any other response? I mean, I am not telling you correct or wrong. I mean, I just asking for anyone. Anyone has any different opinion, or everyone is okay with it? Okay, I think I am okay with your answer. Okay, let's see. So the thing is that just I said earlier, so it is always easier to understand the concept using the fluid flow in a pipe. So if there flow of fluid or liquid in a pipe, or maybe it may not be a pipe, it may be it may be a flat sheet, and it may be a flat sheet and fluid is flowing in the there is space in between and fluid is flowing through that space. It may not be circular in nature. So in both the cases, the cross sectional flow will be basically your parabolic flow, because fluid has got certain drag. There are wall frictions and layer by layer frictions are there. So that's why the element of the fluid that will be at the central region, it will be ahead as compared to other fluid elements. Those are near the wall. Okay, so the fluid is flowing like this way, and now what should happen? The statement, what are the statements saying? The statement one is saying mass transport in advection in along the direction lateral to the fluid flow. So they are saying fluid is flowing in the x direction, and advection mass transport due to advection will occur in the y direction, that is in the radial direction, which is basically wrong, because advection only occurs due to the bulk motion of the fluid. So bulk motion of the fluid is in which direction? Y direction, x direction. So that's why statement one is wrong. Advection will lateral direction, that is your y direction, advection will not occur. And statement 2 is saying that in diffusion mass transport is more apparent in the direction of the flow. So diffusion actually is a slow process as compared to the fluid flow or liquid flow. So diffusion, so if you just wait for diffusion to occur in the x direction, it will be so slow that before the diffusion occurs, the bulk motion of the fluid itself will carry this particles from the from x1 to x2 direction, right? But there is no bulk motion of the fluid in the y direction, so there may be concentration gradient. For example, you take a probe and you just introduce a particular dye here. So due to the motion of the fluid in x direction, the dye will form a line like structure, right? That is your advection. But after certain distance, after the flow has gone up to a certain distance, you will see that there is radial mixing taking place. That means instead of the central line, the entire fluid region is becoming, if you have introduced blue color, you will see that entire region is becoming blue in shape. So that is your diffusion, which is occurring in the lateral direction of the flow, not in the direction of the flow. That is your y direction is the lateral direction, and x is your direction of the flow. I hope you are able to imagine the picture, and which actually falsifies the second statement also. So both the statements are false, as someone has correctly said. Hope this is clear. The advection and the concept, the concept of advection and the diffusion is clear, I think. So if you, for example, you are simultaneously there is a flow in the x direction, there is a flow in the y direction, and simultaneously you are heating the surface also. So because of the heating, there will be again a component of the fluid motions inside the channel. So that will contribute to the flow of these species also, due to of the bulk motion of the fluid. So that will be due to the thermal or density motion due to density difference of the fluid. So that will be called as the convection. Okay. So because of the mechanical motion or because of the thermal motion, sometimes the bulk flow due to mechanical and thermal, they are clubbed as the thermomechanical, and their convection and advection terminologies, their contribution to the mass transfer coefficients are actually clubbed together. So sometimes they are clubbed. Not sometimes, the most of the times they are clubbed because to make the design easier, basically. Or what happens in most of the cases, there is either the thermal component or the uh, mechanical component. Both the components generally are not there, so it depends on from case to case basis. But the diffusion component will always be different, and they will have distinct they will have their distinct contribution in the calculation of the mass transfer coefficient. Okay, so the
Sir, what
next,
is this separation field in the picture?
this is nothing. This is just a, I have taken this picture from a membrane journal. So there is I mean, uh, actually these two channel top and channel bottom, these two are basically your membranes. So that's why there is osmotic pressure difference also. Okay, so that's why the species is also actually passing through the membrane. So that is your separation field. I have taken this picture from there actually, so that's why it is shown here. It is a, you don't need to worry about this. Okay. So here it is. I mean, I have not stated this thing. This will come in the latter. So many fields may come for the water treatment purpose. So here it is. Here the field is responsible for the transfer of the pieces across the border. That is your membrane. As I'm a membrane scientist, so that's why I am, my research area is membrane. So that's why I am most comfortable with those areas, and I have taken this picture from such a journal. So that's why. But to understand that thing, you just imagine that separation field is absent, and the channel top and channel bottom, these two are your impermeable. Impermeable means they cannot, they are not permeable. So these species cannot, either the water or the, neither the water nor the species can get transport across the wall. It will only remain within this region only, and then you understand the concepts of advection, convection, and diffusion. Is that clear? I hope so. Okay. So now, let's see. Anyone has asked any question in the chat box? No. Okay. You can ask. I mean, you can, even if you have not understood, you can again ask, or you can. I mean, I am just a student like you. I am just telling you from my understanding level. So if you are having any challenging, I mean, if you don't agree also, you can tell that, see, I don't agree with it. I will again come with a better, so better explanation of this in the later classes. There is nothing that I am telling is absolute, not like that. I am just telling from my level of understanding. So even if you disagree with some concepts, you can always challenge. No problem with that. Okay. So now, so the separation field, which was there in the earlier picture, so that was not relevant for now for your current assignments. That will come in the later. Okay. So now, molality versus normality. These three concepts I will clarify before proceeding to our next problem. Okay. So can anybody from the audience say what are all these three, or I'll just proceed with the definitions.
Molarity is the number of moles of the solute in 1 liter of the solution.
Yes.
And normality is number of gram equivalents of the solute in 1 liter of the solution. And molality is in 1 kg, number of moles in 1 kg of the solvent.
Yes, definitely. You are correct. Okay.
So by the way, I'm a chemistry. I'm an associate professor of chemistry.
Oh.
It can't be wrong.
Yeah,
It can't be wrong.
I forgot. Sorry.
It can't be wrong.
Whom I am telling? Okay, yeah. Yes. So, yes, for the other audience, I will again repeat what he just said. So, molarity is expressed as the moles of solute per liters of solution. Symbol is capital M. Molality is small m. It is expressed as the moles of solute per kgs of solvent. And normality is gram equivalents of solute per volume of solutions in liter. So now, if you consider water, what is the concentration of water? Water concentration is basically your 1 gram per cc, right? 1 gram per cc means 1 kg per liter only. So in water, if the solution is dilute, that means if the species that is dissolved inside the water, that is not contributing much, uh, in the total mass of the solution, dilute solution. In that cases, sometimes molarity and molality will be interchangeable, and normality will also be equal. If you see the valency is 1, we'll see what is the normality, what is the gram equivalent weight, basically we'll see. But and it changes, the equivalent level changes when what happens when the valency is more than 1. So we'll see it with an example. So let's say we take the compound calcium carbonate. Now there is the molecular weight of calcium carbonate will be 40 is the atomic weight of calcium. Carbon atomic weight is 12 and oxygen atomic weight is 16. So 3 into 16 is 48 plus 12 plus 40, 52. So 52 plus 48 becomes 100. It is the molecular weight of calcium carbonate. Molecular weight means 1 mole of calcium carbonate is of 100 gram. Okay. So now if we ionize the calcium carbonate, if we just divide it into its components, how they are forming bonds, so there may be your covalent bond or that may be ionic bond. It depends on case to case basis, but you can see that calcium is more electropositive than the carbonate. So if we ionize them, calcium will form cation and carbonate will form anion, and there are plus 2 charges. That means its valency is 2, and equivalent weights becomes your molecular weight divided by this charge, that is 2. So it becomes 100 by 2 equals to 50. It is the 100 is your
Molecular weight.
molecular weight and V is the valency. So it becomes 100 by 2 equals to 50. It is your equivalent weight. And now what is gram equivalent? Let's say in a solution, the unit is milligram per liter. That means this many milligram of a particular species is present in a liter of solution. Then we divide that. If we divide that amount, that gram, with this 100, that is your molecular weight, then it gives you the number of moles. And if you divide that same gram with this equivalent weight 50, it becomes your gram equivalence. So if you see that, let's say calcium carbonate, instead of calcium carbonate it is sodium chloride, then what will happen? Then the normality will be equal to the molarity, because here the
So
equivalent.
gram equivalent is simply equivalent weight in grams. That's it.
Yes. So in that case, equivalent weight and molarity will be same. But if the valency is more than 1, then the gram equivalence will not be equal to your number of moles that is present inside the solution. So that's why. I hope it is clear to everyone else. The concept of molality and normality. If someone is not from chemistry background, I am also not from chemistry background. I just did my chemical engineering in BTech and MTech. I did. No, in my first year, these things were there. Okay, so okay, I think everybody is clear with that. Now we'll proceed with our problem. So the concept of calcium carbonate is given as 250 milligram per liter. You have to calculate the following. Number 1 is concentration is ppm, concentration in ppm. Number 2 is equivalent concentration. That is, it is not molality, it is milli equivalent per liter, the unit. Number 3 is the concentration in parts per billion, ppb unit, and number 4 is molar concentration in millimolar unit, that is millimoles per liter, this unit. So these 4 you have to calculate. I hope these questions that I am discussing, these are at par with whatever assignments are given. So if you feel that some question is still left over, some concepts need clarification for solving the assignments problem, you can always ask for it, either in the chat box or in the forum, etc. Okay. So this for anyone, the first one, go with the first one.
250.
Yes. So detailed solution is 1 ppm means 1 milligram per liter. That means option 1 is 250. Now option 2, the equivalent concentration milli equivalence per liter unit. I mean, Usha sir, for you, this thing, I believe this thing will be. This you do every day, so it will not be anything adding value to your learning, right? It will seem boring. So I'm sorry for that. But as it is a general thing, so
No issues, no issues.
no, yeah. So okay. So as I told that NPTEL is a design for general public. So that's why some people, that's why the freedom is given. So if certain things, that's why recording will be also be provided. So if someone, some other urgent work to do, they can always come back to the recording and watch it later, and also the slides will be there. So it only entirely customizable, I think, for based on everyone's personal needs. So okay, some things I believe in later chapters uh, some things will be there for that will really add value to the knowledge, whatever is there you are having. So let's hope so. Okay, we'll also sometimes what happens that people uh, from not very high educational background are attending these courses, so they will understand and also they will ask some basic questions. So what happens by attending the people who are from higher background, they will be understand that what their students, what type of questions their students have, or how they they have to answer. So there are many things that can be learned, not only the subject content, I believe. So even I also learned many things by presenting, because I took NPTEL-1 NPTEL course that was also related to water, but not water treatment, the management aspect of water in the last semester. So I learned many things from my students themselves. So how to
A
present.
good teacher is a good learner too.
Yes, yes, yes. So that is the thing. Okay. So okay, so we'll go with this solution of the second problem. So as we have calculated earlier, the molar mass of the calcium carbonate is 100 grams. If someone has is having doubt regarding what atomic weight and etc., these are there, so they can they can unmute themselves and ask. So I believe otherwise I will assume that they have studied it in your 10th level. What are the atomic weight and atomic number, these concepts are there. So utilizing those concepts, actually the molar mass is calculated. So it is 40 atomic weight is in case of calcium, carbonate is 12, and 16 in case of oxygen, and the equivalent weight is the calcium, as it is 2 plus, so that's why it is divided by 2, and dividing the molar mass with the 2. So 100 by 2, it comes to be 50, and the data given, it is 250 milligram per liter. 250 milligram means 0.25 grams per liter, and 0.25 grams per liter means what? The equivalent weight is 50 gram per equivalent. If you divide this 0.25 gram with this 50 gram per equivalent, so gram cancels out, the unit becomes equivalents per liter. So that means 0.005 equivalent per liter. It is your concentration in equivalent per liter unit. Now the question has been asked in milli equivalent per liter. So milli means 10 to the power minus 3. So 0.005 means 5 into 10 to the power minus 3 equivalent per liter. That means 10 to the power minus means milli. That means 5 milli equivalents per liter. Okay. So it is 5. Option 2. Now option 3, you have to calculate the concentration is parts per billion. So in our traditional Indian language, in Indian unit system, there are ekok, doshok, shotok, hajar, ojud, lokho, nijud, koti. So the nijud, which is before the crores, right? Lakhs and crores. In between lakhs and crores, there is nijud. So that nijud means million, and billion means 1000 million. So 1 ppm is 1000 ppb. That means 1 milligram per liter is also 1000 ppb. That means in case of parts per billion, the concentration will be 250 into 1000. That means 2,50,000. Hope it is clear. So now you have to calculate the molar concentration in millimolar unit. That means 1 mole is 100 gram. 1 mole, it is not generic term, right? 1 mole of calcium carbonate is 100 gram in our case, and 1 millimolar means 10 to the power minus 3 molar. That means 10 to the power minus 3 moles per liter. Now you compare between these two, 250 milligram per liter and 10 to the minus 3 moles per liter. Then you will calculate the concentration. You will be able to calculate the concentration in millimolar unit. So you can see 100 gram per mole is true for calcium carbonate. And if you divide 250 milligram per liter divided by 100 gram per mole, that means your moles per liter, right? It becomes what? Sorry. So if you divide this gram per liter to 0.25 gram per liter is this many grams per mole. So that means 0.0025 grams per mole. Sorry, 0.025 moles per liter. So 0.0025 moles per liter means 2.5 into 10 to the power minus 3 moles per liter. That means 2.5 into 10 to the power minus 3 moles. That means 2.5 millimoles. So in terms of millimolar, the concentration will be 2.5. So I hope all the four are clear to everyone. We still had certain things we will discuss as the times is up. We'll discuss them in the later sessions. So if anybody has any doubt regarding whatever we have discussed till now, you can always ask questions regarding upstream treatment, downside of downstream treatment. What is upstream treatment? What is downstream treatment? What are important in case of upstream and downstream? These are all very basic concepts of water treatment, because the term is water and wastewater treatment. The water essentially means the raw water before use, and wastewater means water after use. So it may so happen the water that is wastewater to some industry becomes the raw water of other industry. So for if you consider a wastewater treatment plant, the raw water of the that the feed water of the wastewater treatment plant is the wastewater itself, and the water that is coming out of the wastewater treatment plant becomes raw water for upstream processes, right? So it entirely depends on the where your focus is, the upstream and downstream water and wastewater treatment, and its relevant parameters. So there are environmental norms. There are for drinking water, let's say there is one guideline in IS, Indian Standard 10500, I guess 10500 2012. So it is utilized for determining the drinking water standard. So as the application varies, as the target from where you will be throwing that water, that as that varies, the norms, the parameters also changes. Accordingly changes the standards and their regulating agencies. So I think these basic concepts must be there. We go forward, and also whatever I have discussed till now. If nobody has any question with that, we can go with other questions, and also the additional questions that will come for week 2 in our next session. So it is 9 and okay, so goodbye everyone. We'll close this session now.
Okay. Thank you.
Bye. I'll stop the recording.